Good morning, students. In the last video or in the last class, we saw the properties and the characters of atom and the composition of atom. So atom and we came to know after all study after doing all the studies, we came to know what are the fundamental particles does the atom has in it. So after knowing all those fundamental particles, what we saw in the last class is the fundamental particles are electrons, protons, and neutrons. We saw in detail about these three, and we also saw what is the charge on electron, what is the charge present on the proton, and what is the charge present on the neutron. And finally, we came to know electron has negative charge, proton has positive charge, and the neutron does not have any charge. So, and even we saw the mass of electron, that means minus 1.6022 into 10 to the power minus 19. In the same way, for the mass of proton, what we saw is plus 1.6022 into 10 to the power minus 19. We all saw in or we studied in the last class. In today's class, very importantly, we study about after knowing the character and the some of the characters of the electron and the behavior of electron. Now, one we can study about the electron, how to fill these electrons in the atom or atom of cells. So, before going to that main topic, again we see some of the extra character of electron, which is very important before filling the electrons into the separate orbits. We have to know what are the important required character for the electron to fill into the different shells or subshells of any atom. So let us have some extra character. See, according to Bohr's atomic model, I think you had these topics in your lower level 9 or 10. So Bohr's atomic model, according to that model, electron is always having negative charge. Very important. These points are, note down these points. These are very important. Electron always carry negative charge. First point. So according to Bohr's atomic model, what he suggests is, the second point is, electrons are arranged in different energy levels. Say for example, energy level n is equal to 1, energy level n is equal to 2, energy n is equal to 3, and energy level n is equal to 4. In the same way, by number he has denoted n is equal to 1, 2, 3, 4, etc. By alphabetic order, he said n is equal to 1 is nothing but K shell, n is equal to 2 is nothing but L shell, n is equal to 3 is nothing but M shell, and n is equal to 4 is nothing but N shell. Right? So you saw these diagram, right, in your book of your lower level. So n is equal to 1 is nothing but K shell, n is equal to 2 is nothing but L shell, n is equal to or third energy level is nothing but he denoted by M, and fourth energy level he has denoted with the letter called N. So in the same way, what does he indicates? What all these indicates? That means, see, in the first energy level or n is equal to 1 is consists of only one subshell. So these are called as K, L, M, N are called as cells. Right? Very important. And these things, that means S P, D and F. Say for example, I will write here S, P, D and F are called as subshells. K, L, M and N are called as shells, and S, P, D and F are called as subshells. So these subshells are present in the main shells. That means how they are, how they are distributed, we will see now. So in N is equal to 1th cell, right? In N is equal to 1th cell or number 1 cell or number 1 energy level is nothing but K shell, and this K shell consists of only one subshell, that is S. So in the same way, N is equal to second energy level is nothing but L shell, and this L shell consists of two subshells S and P. So these are shells. I will write again, it will be very clear. Cells and subshells. These are the cells and these are the subshells. So now N is equal to 1th cell is nothing but the name of that shell is K shell, and thus this K shell, it consists of subshell called S. In the same way, in N is equal to 2 is nothing but L shell, and in L shell we have again two more, that means subshells, those are S and P. Now moving to third cell, the third cell is nothing but M shell, right? And in M shell we have three subshells S, P and D, very important. So this M shell consists of three subshells, those are S, P and D. In the same way, N is equal to 4th energy level or 4th cell is nothing but N shell, and this N shell consists of 4 subshells, and those are called S, P, D and F, right? Now after knowing these, we come to know what are the subshell present in any atom or molecule, and these subshells are mainly depend on the number of electrons. If the number of electrons are more, then our electronic configuration may move up to F subshell. If the electrons are only 2, then our electronic configuration will restrict only to the S subshell only, right? So depending on the number of, as the number of electron increases, the electronic configuration goes on increases. So this is the next thing, second point about Bohr's atomic model of electron. And the third point is, what he suggests is, whenever already we drawn one diagram, see, these are different energy level diagram, and so now third point, what he says is, each and every cell has their own electron, but very important, this point is very important, listen carefully. Whenever electron revolves around its particular cell, if the electron revolves, the electron which belongs to N is equal to 1th cell, while revolving in that particular cell, definitely it neither gains the energy nor loses the energy. Very important. Electron, whenever the electron revolves in the same cell, it won't gain the energy or loses the energy. Very important. When electron gains or loses energy means, say for example, consider this as one atom and these are the electrons, and consider that we are applying some physical change. That means by applying external temperature, we are just changing the energy. That means we are applying the external energy to the this atom. So thus now after applying this energy, definitely the electron present on the outer cell consider here, this is the outer cell electron. This electron directly absorbs this temperature, and definitely if it absorbs the energy, then it will jump to higher energy level. If it decreases its energy or loses its energy, then definitely it might come back to its another energy level. That means n is equal to fourth electron may come to n is equal to 3 or n is equal to 1. This is very or n is equal to 2. This is very important point. That means electron always retains its energy when it is revolving around the same cell or in its particular cell. But when it increases or decreases the energy, when we apply external force or external energy in the form of chemical energy or in the form of physical energy. So these are the some extra characters. I am not going detail about Bohr theory, but what are the characters we need now for electron filling rule, that much only I am just going through. So now after knowing these things, that means electrons are negatively charged, electrons are present in different energy levels. That means the energy level maybe n is equal to 1th energy level or 2nd, 3rd, 4th, or electron may present in the K shell, L shell, M shell or N shell. That means all the electrons carries the same charge, but depending on their energy, depending on their shells, their energy and size may change, right? And the third point what we saw is electron neither gains energy nor loses the energy when it revolving around in its same shell or same subshell. When it increases or decreases the energy means when we apply some external force on it, right? So after knowing these things, we directly go into the rules. So there are three rules for electron filling. So the first rule is Aufbau rule. Aufbau rule. Number two, Pauli's exclusive principle. Shortcut I will write Pauli's principle. The actual name is Pauli's exclusive principle. And the third is Hund's rule. It depends on your pronunciation. Hund's rule, right? So these are the three rules. With the help of these three rules, one we can fill the electrons into the different energy levels. So first we will see what Aufbau rule says. So before going to Aufbau rule, we need to know a very small thing, that is what we saw is different, that means S, P, D and F subshells, right? Just now we saw there are 4 subshells present in the atom or in any molecule. So that means S subshell. What is S subshell, P subshell, D subshell and F subshell? Before going to the rule, we have to know the character of these things. So S subshell is nothing but, here the S subshell has only one orbit, right? Or you can say, normally you can say this as just as box, right? Number one. And the maximum number of electron present in the S subshell are 2. Very important. So S subshell is having only one orbit, and the maximum number of electron present in the S subshells are only 2. Very important. Now coming to the P subshell. In P subshell we have 3 suborbits, and those 3 suborbits are in particular Px, Py and Pz. These are the 3 suborbits, right? So that means here the maximum number of electron present in the P subshells are 6. Very important, right? The maximum number of electron present in the P subshell, the p subshell is 6. That means it will not extend more than 6, or in s subshell it will not extend more than 2. It may be 1th SSL or 2nd SSL or 3rd SSL. The electron must and should, or the maximum number of electron present in 3rd cell or in 2nd cell or in 1st cell or in 7th cell, that should be 2 only. That rule we have to follow, right? So now in p subshell, the maximum number of electron present will be always 6. So now coming to D, right? So coming to D subshell, so D subshell has 5 suborbits, very important. D subshell has 5 suborbits, and those orbits are in particular dxy, dyz, dzx, dx square minus y square, and last one is dz square. We see the structure and all in the theory classes, I mean in topic, right? So now you just remember there are 5 subshells, suborbits in the D subshell, and those are dxy, dyz, dzx, dx square minus y square, and dz square. And the maximum number of electron present in the D subshells are 10. It will not extend more than 10. Either it may be a 3rd D cell or 4th D cell or 5th D cell. The maximum number of electron always be 10. And now finally F. So F is having, we know just about the 14 electrons. Maximum number of electrons present in the F may be 14, but we don't know, still the study is going, we don't know what are the suborbits and how many suborbits in actual present in the F. So after knowing these things, one we can move to the rule called Afabo rule. So Afabo rule is very important, and it is a very basic part for filling the electrons in the different subshells. So why? Because see, this rule explains about, or it states that the electron move first into the lower energy orbit. Electron moves into lower energy orbit, very important orbit, and then it moves into higher energy orbit. So this definition or this statement explains like how the electron enters into the different suborbits. Now what he says, electron moves into lower energy orbit. That means first he says that electron first enters into those orbit who is having low energy, and then orbit, and then it moves into higher energy orbit. That means what he suggests is lower energy orbit fill first, and then the electron, if the extra electrons are remaining in our orbit or in our with our atom, then the higher energy orbit will be filled. Then the question will arise, how to identify higher and lower energy orbit? So we don't know which orbit is lower, which orbit having lower energy, which orbit has higher energy. So that's why what he says, he has given one rule. Later in the class I will explain, but for the sake of filling, you just try to understand. According to him, first 1s orbit will be filled. If the electrons are more, then we will move to the second orbit. That means number 1 and number 2, right? Number 1 and number 2. That means one cell is having number one cell is having low energy as compared to the second cell orbit or second cell. So that's why the electron first move into the first cell. That means n is equal to one cell. N is equal to 1, n is equal to 2. I had shown you, right? So starting this video, before starting this video, I have shown you that now n is equal to first cell is lower energy orbit, and then energy increases in second, again in third, in fourth cell, like how the energy goes on increases. But in case of first here, in this case, the first orbit will be filled. Then if the extra electrons are there, then the second the electron will move to the second, like how after 2s the electron will move into the 2p, and then 3s, and then 3p, like so on. That means these are considered as lower energy orbits, and these are as we move from left to right, the energy goes on increases. These are the very basic thing you might have saw in your lower classes, right? So according to this rule, I think you understood this rule. According to this rule, electron moves into the lower energy first, and then the electron moves into the higher energy orbit.